Hey guys, so we are doing more elimination for systems. So still kind of method number 3, but I call this method number 3 with a twist. Some people will call it method number 4 because you are doing something a little bit different, but it's still elimination. So go ahead and print out these notes, or if you don't have them, maybe pause the video here, get some lined paper, and write these examples down. If you take a look at the examples, you're going to notice that none of my variables can cancel. I have 8x and 4x. 8 and 4 cannot get to 0. 3 and 5 can't get me to 0, nor are any of them opposites. Same thing here. 2 and 3 can't get me to 0. 1y and 5y can't get me to 0. I have opposite signs, but not opposite numbers. So for this lesson, up at the top here, it says, we know how to solve a system using elimination, but sometimes there isn't a variable that can cancel nicely. Nicely meaning we have 4 and -4, 10 and -10, 1 and -1. That means we need to make either x or y opposites so that they can cancel. To do this, we need to multiply one or sometimes both of the equations. We still need everything lined up. We still need to have opposites. So I'm going to go ahead and I'm going to zoom in on example 1 over here, and let's kind of talk about what we're going to do. Notice none of my variables are opposites. I don't have opposite signs or the same numbers. So what we need to do is we need to multiply. Now, can we look at the smaller number to get to the bigger, because that's what multiplication does. Can I get from 4 to 8 by multiplying, or can I get from 3 to 5 by multiplying? You can get from 4 to 8 by multiplying by 2. So I take this whole equation and multiply it by 2. Because if I do 2 times 4x, that will get me my 8x, so that then they can cancel. So what I'm going to do is I'm going to multiply everything by 2, and I'm going to rewrite the whole equation. So this equation will become, and I put it in parentheses because we're going to do the distributive property. 2 times 4x is 8x. 2 times 5y is plus 10y. 2 times -7 is a -14. This is the number one mistake people forget, is they forget to multiply this third number. Don't do that. Now I also need to make sure everything is lined up, so I have to rewrite that top equation above. 8x plus 3y equals -21. So now I have everything lined up, x's, y's, and equal signs, but I don't have opposite 8s. I have 8 and 8, but I need a +8 and a -8. So I need to make one of them negative. So if I make this 8 -8x, I also need to make the 10 negative, and I need to make the 14. It was negative, but I need opposite, so positive. And then I can put my line in, and I can add. 8x plus -8x cancels, because 8 plus -8 is 0. 3y plus -10y, 3 plus -10 is a -7y. -21 and a +14 is a -7. And now we're back to what we've been doing earlier this week. We have a one-step equation. Divide both sides by -7. They cancel. So I have y equals -7 divided by -7 is a +1. So the only thing that's different here is that very first step. You always will have to multiply one of the equations by a number if you don't have the same numbers. Then I take this one and plug it back into either of my equations. Now this one's a little bit trickier. You can plug it into the top or the bottom. If you remember, I look for the positive variable. In this case, 8x and 4x are both positive, so it doesn't matter which one we plug it into. Then you can kind of look and pick. I would suggest the one that has maybe the smaller numbers or ones that look a little bit more friendlier. So I'm going to plug it into the bottom equation, but it really does not make a difference if you plug it in the top or the bottom. You'll get the same answer. So I take this 1 and plug it in to y. So I have 4x plus 5. Instead of y, I put 1 equals -7. So now we solve for x. And I have 4x plus 5 times 1 is 5 equals -7. Two-step equation. Subtract 5 on both sides. Those 5's cancel. 4x equals -7 and -5 makes -12. Divide both sides by 4. And x equals -3. And our answer will be written as a point. So -3, 1. And you have to put it in parentheses like that to show that it is a point on a graph. Okay, that was example number 1. Let's slide over to example 2. 2x minus y equals 2, and 3x plus y equals 16. Can I get from 2 to 3? You can, but you'd have to multiply by a decimal, so I would not suggest that. Can we get from 1 to 5? Yes. Sometimes you multiply the top equation, sometimes the bottom equation, but you always multiply the smaller one. So I'm going to multiply this whole equation. 1 times what gets me 5? 5. So I'm going to do the distributive property to the whole equation, and I get 5 times 2x is 10x. 5 times 1y is minus 5y. 5 times 2 is 10. So I have a new top equation. Remember, everything needs to be lined up, so I'm also going to rewrite that bottom one, which was 3x plus 5y equals 16. And we have 5 and 5, so that's good. And we have a negative and a positive, so we don't have to change anything, so we can proceed. So I put my line down. 10x and 3x gets me 13x. Negative 5y and 5y is 0. That's the point. 10 and 16 is 26. Divide both sides by 13. And what do you get for x? X equals 2. Now we have to find y. So I'm going to have to plug it back in. I can plug it back into the original top or the original bottom. The original top has smaller numbers, but the original bottom has that positive y, and y is what we're looking for, so I'm going to plug it in to the bottom. So I'm going to take 2 and plug it into x on the bottom equation. So we have 3 times 2 plus 5y equals 16. 3 times 2 is 6. 6 plus 5y equals 16. Subtract 6 on both sides. And we have 5y equals 10. Divide both sides by 5. And what do you get for y? Y equals 2. So that means my two lines, if I were to graph them, will intersect at the point 2, 2. So remember, it's x, y. Okay, that was example number 2. Let's do a third one. Example 3. I have 3x minus 4y, and I have x minus y. I'm going to cover that up there. Now, notice, I can either multiply this equation by 3 to cancel my x's, or I can multiply by 4 to cancel my y's. It does not matter. In my suggestion for this would be always multiply by the smaller number. I also have both positive x's and both negative y's. So something is going to have to change, so it doesn't matter. So let's multiply the bottom one by 3. Could have done 4, doesn't matter. So my new bottom equation, 3 times x is 3x. 3 times y, keep that sign, is minus 3y. 3 times 1 is 3. There's my new bottom equation. Then the top, I need to keep everything lined up, so I'm going to rewrite that one. 3x minus 4y equals 0. Now, I have 3x and 3x, so that's the variable that's going to cancel, but I don't have opposites. I have a positive and a positive. So I need to make this one a negative. If I change x to negative, I need to change everything else. So this minus 3y becomes plus 3y, and this positive 3 becomes negative 3. And now we can solve. Go ahead and try this question on your own. Negative 4y plus 3y is a negative 1y. 0 minus 3, negative 3, divide. You should have gotten y equals 3. Now I need to find x. Plug it into the top or the bottom. They're both positive, totally up to you. I'm going to pick the bottom one just because this one has a smaller numbers maybe. So I take this 3 and plug it in for y. So I have x minus 3 equals 1. To get x by itself, I'm going to add 3 on both sides and get x equals 4. What would be the point that these two lines would intersect at? They would intersect at 4, 3. Okay, last example, example 4. X plus 3y equals 4, and 3x plus y equals 4. Now notice for this one, you have a couple choices. I can multiply the top by 3 to get 3x, or I can multiply the bottom one by 3 to get 3y. It does not matter. You could do either one. I'm going to choose to multiply by the top. Doesn't matter though. If I want to get the top, I need my x's to match, so I'm going to multiply by 3. Using the distributive property, this equation will become 3x plus 9y equals 12. I need everything to be lined up, so I'm going to rewrite that bottom equation. 3x plus y equals 4. Now I have 3x and 3x, so what do I need to do? I need to make one of my equations negative. So it's a negative 3x, means I need also a negative y and a negative 4. Then we solve. I'm going to go through kind of quickly here, so you can pause it if you need. 3x minus 3x cancels. 9 minus 1y is an 8y. 12 minus 4 is 8. Feel free to pause if I'm going too quick for you. Divide both sides by 8 and get y equals 1. Then we got to find x. Doesn't matter which equation you plug it into, they're both positive. So let's say, how about this time we plug it into the top one? Could have plugged it into the bottom though, it's totally up to you. So always the original. X plus 3, instead of y, I'm going to put a 1, equals 4. So we have x plus 3 equals 4. Subtract 3 on both sides. And I got x equals 1. So the point that these two lines would intersect at, if we were to graph them, would be 1, 1. All right, that is all of method number 4 or 3.5, whatever you want to consider it to be, elimination with multiplication. All right, guys, reach out if you have any questions. Have a good day.